So class 10 students, today we will do again a new exercise. Okay, that is exercise 1.4. So what is the question of question number 1? You see clearly, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So you have already studied in class 9 what is terminating decimal expansion. Okay, terminating decimal expansion, you see terminating and non-terminating. That means what? You have already studied in class 9, yes or no? So you have already studied in class 9. This is terminating and non-terminating. Terminating, that means what? If the number stops, understand, if the decimal expansion stops, that means here if it doesn't stops, understand, if it doesn't stops. Non-terminating repeating, okay, this one repeating, non-terminating repeating, that means what? It doesn't stop, and if it will be terminating, it stops. Okay, so this you have already studied in class 9. I think you recall it back, okay, to understand it. I won't explain you because this is not your syllabus. Then how you will do this? You will find out without performing the long division. That means without calculating by this we used to do that in class 9. So we will take this, we will divide, after that we will put this bar, this and that. We won't do this, okay, because it is not your syllabus. We will do by without calculating or without performing the decimal expansion. So how to do this without performing without calculating? You need to see the theorem 1.5, okay, theorem 1.5 to 1.7. You see clearly, if you will see this theorem 1.5 to 1.7, you will see that if x is can be expressed in the form of p by q, p and q are co-prime, p and q are co-prime, understand, p and q are co-prime, and the prime factorization of q, will be 2 to the power n into 5 to the power m, where n and m, okay, where n and m are positive integers. Non-negative integers, that means what? Positive integers, yes or no? Non-negative integers, that means positive integers. That means n and m will be positive integers, okay, they won't be negative integers. You remember this. So by using this formula, we will find out without calculating or actually performing the long division method, okay. So how to do this one, you see clearly here. I will explain you, okay. So number 1, first you need to see this denominator, okay. Why? Because in the form of p by q, where q is what? Is in the form of 2n into 5m, yes or not? Q is what? Q is denominator, yes or no? P is 13, p is numerator, q is denominator. So q is denominator, so you will find out denominator in the form of 2 to the power n into 5 to the power m, okay. So first you will take the prime factorization of this, okay. So you have already studied in class 6 class 5 how to take out prime factorization. You recall it back, okay. So it's better, or it's very important to study each and every chapter of classes, understand. If you studied very well in class 6 class 7, then you won't forget the method of prime factorization, this and that. It is all related with each other, okay. So you study nicely, or if you don't remember, you recall it back again, okay. So this we will take out the prime factorization of 3125. How to take out prime factorization? First, you will do by 5. 5 ones are 5, 5 6 are 30. Yes, and 5 2s are 10. Because 30 here 1, 12, 5 2s are 10, 5 5s are 25 because 2 is left. Okay, then 5 6 are 30. No, 5 6 are 13. 5 12s are 60. Here 5 5s are 25. Here 5 2s are 10. 5 5s are 25. Here 5 5s are 25. So the prime factorization of 3125 is this. Okay, that means 3125 equals to 2 to the power 5. 2 to the power 5, that means, oh, 5 to the power 5, sorry. 5 to the power 5, that means there are 5 5s. 1 2 3 4 5 5, yes or no? So 5 fives. Okay, so you will write here, since, okay, since the factors of 3 1 2 5 are in the form of 2m, 2n, yes or no? So 2n, that means what? N is not there, 2 is not there, so you will put 0 here. Okay, 5 to the power 5. Okay, therefore 13 by what? 3125. Yes, 3125 is a terminating decimal. Okay, so how you will find out terminating decimal or non-terminating decimal? If it is in the form of 2n, if it is in the form of 2n, 5 to the 2 to the power n into 5 to the power m. If it is in the form of this, it is in the form of this, yes or no? So it is terminating decimal. So if it is not in the form of 2 to the power n into 5m, then this won't be terminating. Okay, this will be non-terminating decimal expansion. Okay, so this is question number